The notion here was really to kind of spin out what I thought was a fascinating remark that you made, which is that essentially either all of WinFS has shipped or will ship in some form or another.
Most of it, yeah.
And I think that's certainly a surprising remark. I think it will surprise a lot of people, and I would be interested to hear exactly what you meant by that.
WinFS is really about different things, right? In part, it was about trying to create something for the Windows ecosystem, Windows developer platform around shared data between applications and all this. Mm-hmm. And I'm actually going to put that part aside because that part's not shipping, right? Yep. Because that requires that Windows delivers that. It's part of the Windows ecosystem, and apps are built around and all that stuff.
So you mean the aspect of schemas that would define contacts and other kinds of shared understandings about data?
In particular, the goal around creating a place in Windows where apps across hardware can share this stuff. Schemas is a mechanism, yes, mm-hmm. Technology required for that. That notion of having the shared data platform as part of Windows is not something that we're delivering in this set of Turn the Cranks. Now, we may choose to do that as a company sometime in the future, built on the technology that we're finishing up here in SQL. But it is not something that's on the foreseeable roadmap, mm-hmm. on the immediate roadmap. So that part, you got to wrap that part up and just sort of put it aside. And then you look under the covers of that and say, okay, well, what was required in order to deliver on that goal? It's about schemas, it's about integrated storage, it's about object relational, it's about a bunch of things, right? And that's the layer you can look at and say, okay, so the WinFS project, which started. Well, it depends on who you ask, but I think it started in 2002. It went until we formally shut it down, I guess, in 2006, right? Yeah. What was the technology that was being built for that effort in order to meet those goals, and what happened to all that stuff? And you can sort of go through and catalog all those pieces now and trace work that we're doing now or finishing up now for SQL Server 2008 or for ADO.NET. It's coming out as part of VS 2008, SP1, etc., and trace its lineage back to WinFS. And that's kind of what we can go through.
Yeah, let's do that.
Catalog.
Let's do that.
Okay. All right. So, in no particular necessarily logical order, you can start. I guess we can start at the top. So the very top were schemas. Schemas are not part of. We're not doing anything with schemas. We actually. At the end of the WinFS project, we had settled on a set of schemas. In fact, it was interesting. It was a very typical computer science problem and execution on that problem that we saw go through, where the schemas started out as these very small, super subset of all these things.
Very general.
Yeah, and then they became the inclusion of all possible angles, properties, and interests of anybody interested in that topic whatsoever. I mean, at one point we had context schema with, 200 properties or something, 300 properties or something like that, right? We had, things from all over people's interests in it. And then, by the time, we were, at the beta that we shipped for WinFS, we're back down to that, super small subset of, okay, here's the 10 things about people that you need to know in common across applications, and everything else is app specific and extended as necessary, right?
Yeah.
Built those extensibility mechanisms, etc. But all that stuff is gone. So all the schemas we created this layer that we internally refer to as base in WinFS, which was about the enforcement of the schemas and all the stuff at the sort of store level. All the stuff we put on the shelf because we didn't need it, because it was really particular to that particular application of all this other technology. So that's the one piece that didn't go anywhere. Next layer down is the APIs. So the WinFS APIs were a precursor to a more generalized object relational set of APIs, which is now shipping as what we call now an entity framework in ADO.NET. So in ADO.NET we have, and at least it's coming up as part of, I guess it's actually getting delivered as part of SP1 of Visual Studio 2008, an expression of what we call the entity data model in ADO.NET called the entity framework, which allows you to basically describe your business objects in an abstract form in a fairly generalized entity relational model. In fact, we even got best paper at SIGMOD last year on the model and the work we've been doing there. I mean, it's a very good piece of work. And so it allows you to describe your business entities in that way with a particular formal language, entity language.
So for people who haven't seen this, how would you characterize the language used to describe these objects?
Well, it's pretty standard entity relational. It's not, you express the stuff in XML. It's really a matter of describing to the system a set of properties and collections and relationships between entities that, this is how you think. The important thing we tell people to walk up and describe their business entities as they think about them. Mm-hmm. Not as they think they should be expressed in a fully normalized database schema, or not as they need to program to them necessarily as objects, but in terms of how they think about them, how they want to be able to report on them, or how they want to be able to interact with them conversationally, say. Mm-hmm. And from there, we can derive objects later to program against them. We can derive schemas and store to be able to store them. And that, the trace back of that back to WinFS was, we had a very fixed way of doing this for a particular set of entities in WinFS. In WinFS, we built the schema around items, and items were an entity, and items had relationships to other items. We built this whole model on a more generic substrate that we never expressed, right? And so we said, okay, we're not going to ship the WinFS APIs, but we have this asset in this more generalized expression framework for entities. Let's figure out how to finish that work up and get that delivered as part of the next ADO release. And we had even begun that. We'd begun that work even before we shut down the WinFS project. We weren't sure we were going to do it all, and there were actually. I remember these moments, in project planning back then. Fairly stressed out about, okay, we have this huge value in all this ORM stuff that we are getting demand for. There's a real market around this stuff. We're getting demand from customers for this, flexibility in the programming languages and in the programming APIs for the database. We know how to do this, but boy, doing both is going to be tricky here to get it all delivered on time. And of course, once we stopped doing the WinFS API work, we're able to sort of focus on a lot and get that all on track to deliver. So this stuff is very well integrated with Link. So you can program Link to, you can do Link to relational, which basically Link will look down into the database, look at the schemas there, and express that directly up into Link. Or you can do Link to entities, which allows you to have this layer of abstraction between what you're programming to and what your physical underlying database schema is, which is important in the real world, right? I mean, a lot of app developers, especially IT, in IT departments of large companies, they don't have any control over what the heck is in the database. They're still not going to change the schemas around how they want to program things. So we need that sort of a little flexibility and direction. So that work is going on, and we're targeting delivering that. I guess it's the summertime. I don't know the exact time frame. And that's so far we're getting pretty good feedback, and we'll see how far that technology takes us. And there's a whole another layer of work to do around there, more flexibilities, more semantics in the expression language around entities, more capabilities there, and that kind of thing.
How much continuity is there in terms of the team?
The API team?
Yeah.
On that, for that segment, a lot. I mean, overall. So when I did the reorg, I literally had a Excel sheet of every person in the organization and where we were moving them to, right? Because we weren't riffing the WinFS work, we were moving the work into the core engine. So we had identified areas where these technology areas were going to land, and then the people that went with them and where they're going to fit in organizationally as we went through the change. And I haven't actually looked at that database looked at the Excel sheet in a while, but when I last looked at it about 6 to 8 months ago, 80-something% of the team was still in SQL, still working on technology somewhere.
Yeah.
In the API team, I think that ratio is still probably about that high as well. It's got to be pretty close. I mean, a lot of the key leaders that we had. Because when we did WinFS, one of the interesting things about that project for this group was we started to hire a different kind of person for the database team than what they had traditionally hired. The database team is full of traditional hardcore systems database guys. Lots and lots of them. Very sort of traditional backgrounds. A couple of handfuls of schools that we prefer the good systems development training, education. A lot of them have background at our competitors, that kind of stuff. As we built the program here, you can look across, and there's a fairly similar pattern to a lot of these folks. When we did WinFS, we're looking for a different thing, right? I mean,
actually, you told me that you yourself don't consider yourself to be a born database guy, or one of those types at all. So
that's right. Yeah, I'm a good example of it. Yeah, where I started Microsoft in the Word group. I didn't think I wanted to work on systems. I didn't even think I even wanted to work at Microsoft. It's a longer story, but so I went from Word to IIS. From IIS to I did a project called Application Center, which eventually folded some technology into pieces of Windows, and was in some of the manageability technologies for a while, and then was asked to come over and do WinFS. And so my background was much more around how to use a database, what's it useful for, how do you build apps around them, how do you build apps that can share data across them, because I had to do a lot of the manageability stuff, and not so much the what are the internal algorithms you should use for bitmap indexing, or your favorite database technology, right? So we started hire. Of course, we had a large block of folks that came from the core database team that were working on WinFS. We hired a lot of different folks that had experience with compilers, had experience with user interfaces, had experience building apps on the database, etc. And so a lot of the folks that are now that ended up leading our API effort are now leading our broader API effort for all of SQL. So Sam Drucker is the general manager of data programmability. Was the dev manager of the WinFS APIs at one point. About 4 years ago, whatever it was, 3-4 years ago. Okay. One of his current product managers, was one of his dev leads, and sort of on and on it goes. We hired a guy, Britt Johnston, to come, and he was a CTO at another database company who brought a lot of building ecosystem experience with them. Right? I mean, Microsoft has a huge ecosystem engine that we can use, but to get someone from a smaller company that was more used to working harder, bending over backwards in order to create the right kinds of conditions to get ISVs on board and that kind of stuff was an interesting hire for us, right? So we got that guy. He's still in the DP team as one of our project managers. So yeah, we hired this sort of different profile, and a lot of those API guys have continued on, and they're doing good work. I mean, we're doing a lot of stuff that we're working on, sort of the post NE Framework 1.0, Link 1.0 work that we're doing. A lot of that comes from their background in compilers and languages, etc., as opposed to just core database stuff. So that's the kind of story with the API team. So then the rest of it, well, there's obviously a big chunk around file systems. Right? Mm-hmm. So to do WinFS, we said, boy, if we really want to do this shared data model, you want to have it be applicable to all data, right? So not just about things you can express relationally. So we had to figure out how to merge, database constructs with the file system to allow files to participate in the experience, right, in the data store. And a lot of people thought this was impossible and would harken back to Cairo and JAWS and various other projects announced and unannounced to the public world around integrated storage efforts of ago that all didn't necessarily produce the fruit they were looking to produce. And we had one pretty key advantage, which was we had found an architectural approach that allowed us to control the semantics in a way and provide transactional database consistency over the files that were involved, while still allowing the file system to be in control when it came to file handle level operations. So there's an architectural thing that we did, with a kernel driver that allowed us to control the namespace and allowed us to keep the database involved. The database lives up in user mode, right? And as far as the operating system goes, there's no difference between the SQL Server and Microsoft Word. I mean, they're just they're high-level user mode apps that occasionally drop down and make requests of the kernel. And there was a sort of fundamental disconnect there. So how do we maintain control over this very low-level system concept, right? Which is, the file system, the namespace controlled by the file system, by a user mode level app. And so we built a kernel-level driver, that communicate back with our user mode SQL process to get cache of what the namespace should look like and what things are in what state, etc. But basically, it was there along the API path for the file system to allow it to control the namespace operations over files that were quote-unquote in WinFS, right? Mm-hmm. People often ask me, is WinFS a file system? And I'd struggle with the answer to that because, from a certain standpoint, the answer is yes. Like, what I've been able to, click start, run, type in some path and hit enter, and, the stuff I saw in the shell, was it, in the WinFS file system, okay. But there are no streams inside the database, right? So from a user perspective, from everything that mattered, it was quote unquote in the database, in the file system. But from a API perspective, it was a little bit more nuanced than that, because I could walk up to this thing and I could still use the Win32 find next APIs, get some file. I could do a get file on it, or open file on it, and Win32. And from that point forward, the semantics that it obeyed were exactly like NTFS. It functioned just like NTFS, and it did because it was NTFS at that point. There's a certain place, along the API chain where, below which you started working, and we were, the WinFS part was basically the database part was just completely out of the way. And this allowed us to get the perf compatibility and all that stuff that had tripped up other integrated storage efforts in the past. Many integrated storage effort tried to build this thing by literally emulating all the Win32 API calls, which is hard. There's byte range level locking, and it's tough. And the performance bar is, very, 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 very high.
So how does this aspect of it carry forward, if it does?
It does. So that architectural approach is so good that we said, boy, we can really generalize this for the database. So we have a feature in SQL Server 2008, which I'll sometimes refer to as Catmy, it's a code name, called FileStream, which is basically a new kind of blob support for the database, right? Where you can walk up the database, you can configure a column, for FileStream, and you can take files, insert them as records, basically, and you get back a file handle, and you can stream things into that file handle. You can do queries, you get back file handles, you can do create file in that file handle, and get streaming API level NTFS performance on the files that you put in there, the file streams you put in there. What we've not done is the namespace support. So you don't get to kind of walk through a hierarchy and directory of files. You examine a row, okay. You ask that row to give you back the right token that you can start doing the Win32 operations over it on. But the rest of it's integrated. You boot back up the database, back up the file streams. From most database perspectives, the exception actually of mirroring, the one feature we didn't get to fully integrating in 2008, it just looks like any other blob. Just looks like a piece of the database.
And where do you see that being used to good effect?
Well, right now there's this choice people have to make. Right now, there's a size limit on how big blobs get in the database. There's still one problem there because we put them inside database pages, and so that leads to a performance problem as well. So you want to do streaming. You want to pull a 2 gigabyte record, 2 gigabyte stream out of the database. With traditional blobs, it's not as performant as walking up to NTFS, right, and going and doing this through a file handle.
Right.
Because we have to recreate the file by putting together a series of pages, database pages, that are themselves all of indirection on file system pages, right? So there's this level of inefficiency that you can never kind of really get around by just putting the blobs inside the database pages, database files themselves, database records themselves. So you get the best of both worlds. So people today have to make a choice. Okay, well, do I want the integration of the database so the backup works and my database semantics, transactional semantics, all that stuff works? I can program to it as database constructs and live with the performance and the size limitations that are there, right? Or do I want great, the best possible performance and no limitations, basically no limitations on size of the files, etc. Right? Yeah. By putting them in the file system, and then and then my application logic figuring out how to glue together the database world and these files that are now strewn about the file system. And, when I do a backup, then I also have to worry about, I've got to teach my operations guys that, well, okay, when you back up the database, you're not actually backing up all the data, so you also have to worry about these files that are now somewhere else in the database and something about, on and on it goes, right? So people today make this choice, and with FileStream, people get to no longer have to make that choice. They basically get the performance they want with it being integrated with the database in the ways they expect. Now, the next place to take that after 2008 is by adding the Win32 support. So we did this other feature as part of WinFS that we internally refer to as OrdPath, which I think the official name we're calling it in 2008 is Hierarchical ID as a column type. So it's a new data type, new column type, which is hierarchy support in the database. Support for hierarchical data. So we did this for WinFS because, obviously if you have a bunch of files and you're storing all of your data in a file system like Hierarchy, you need to be able to do things like show me all the stuff in this folder. You need to be able to answer that query lickety-split, right? You can't be like, walking through record by record and seeing if you have, matches. So you need to,
or dealing with the SQL way of expressing hierarchy, which is doable, but kind of beyond my comprehension to do. So
it's hard. It's hard. I mean, the fundamental problem is that the query processor doesn't understand path, right? I mean, it understands, matches on columns basically, and its ability to find, it can find substrings within records. It's a like operator, right? But it's kind of brute force, and there's no real indexing on that, etc. You can do some full text indexing, but you're not going to show what's in this folder here, particular folder.
You don't get containment falling out for free. So.
That's right. And so what what hierarchical ID is a column type that teaches an index in the optimizer about hierarchy and about path. And so you can create your own path type, and you can populate a column, inside a table, and you can do queries, and you can do things like show me all the stuff that's contained within this part of the path, and that stuff is indexed correctly and all that stuff. So we have that feature also shipping in 2008, and we have all sorts of different uses for this. People people use it for compliance. So they'll create a hierarchy of different confidentialities and compliance levels, right? So I need this thing is confidential, which is really a superset of things that are executive eyes only and this other thing. And people have these hierarchies for things like compliance or for scientific applications or a bunch of different things. There's just hierarchies out there in the world.
And how do you build and visualize these things?
That's a good question. I don't. You come, you tell us about them. You express the form of your hierarchy, and then you just populate the records as you would any other database data. But I don't know if we have much of a tool around, developing that kind of stuff. I suspect.
So there's the file stream piece, and there's this hierarchical ID piece, but as you said, it's the Win32 namespace piece is the shoe that hasn't really dropped yet.
And in the next release, we anticipate certainly putting those two things together, the file system piece and the hierarchical ID piece, into a support namespace. Okay. So you'll be able to walk up the database, configure the thing with the right kind of hierarchical ID and file stream configuration, do some other table level configuration, and then after that point you'll be able to do start run, whack, machine name, share name, pops out of an Explorer window, it's empty, responsibly. Right. Drag and drop a file into it, go back to your database, do select star, hit enter, and suddenly a record appears. Right? Okay. And from that point forward, as you create folders and as you navigate that namespace, from the Win32 side of the universe, it looks just like MTFS. Just looks like a file system. So
there's you wouldn't even need to do a special PowerShell adapter. It would just be right there. It would just look like
the goal is just to let Word open a file out of the thing, right? Yeah. And potential uses for that. Well, it's all over the place. You go to any company these days, or that have apps deployed, like take our own expense reports, right? In our own expense reporting system, they've recently reintroduced the ability to have an offline form. But once upon a time, we used to have these Excel form templates, and you could go and you could fill this thing out, and you could and then you'd submit it to some system somewhere. This is before we built all these internal web-based apps. And then we went through this phase where it was all online, which meant you're on the plane home, walking through your seats. Too bad for you. Like, I guess you could take some notes in Excel and then later transpose them into the tool, but that's not going to really help you, right? But imagine they can reduce that template again, and you can save that Excel file directly into the database. Or more importantly, if you go to edit the thing, you don't have these, you don't have this process where you've taken a copy of the thing, you're editing it, and you're sending it back through a mid-tier system that then has to reconcile, making the database records and the file system record, making those, reconciling those things. But I can just say, oh, okay, I need to add 3 more things. I can double click on that thing, right? I mean, yes, I'm still interacting with some web-based app, but the links I get are real Win32 links. I open the thing, I edit it, I stick it back. Everything knows that the thing has changed. It's changed within the right, transactional semantics. So there are applications like that. We take photos for badges and press and stuff here at the company, right? And there's this app, but they generate these big trees of files that have all this made. They have their own little workflow app associated with all this stuff, and those things get asked, I think, all the time. They're having to they delete some of these things because they don't know anything about them anymore because they got lost in the workflow. People are constantly having to bridge this notion between the file world and the data around the files world all the time, and providing them with Win32 access just gives the app developers the opportunity to allow the desktop clients to directly interact with a file that's part of some application without having to necessarily go through all the semantics of going back through the mid-tier and all that. So I think there's a big advantage to providing this. I think that applications will find interesting uses for it. And are there always going to be some of course there are going to be some apps that are going to want to have mid-tier control over every aspect, every part of workflow of everything coming out of some application. Of course. But from a productivity standpoint, to be able to allow people to go and build applications more quickly, allow people to customize applications and not have to manage all those semantics themselves. Imagine we build the right, sync is another topic, but imagine we build the right things around synchronization, so the files, they come back, you can take them offline. And this all kind of comes for free as a developer. It's just a major productivity gain where you know of a certain consistency of the world you're dealing with because you're not having to create, manage, and update and upload and deal with all these copies all on your own.
Yeah. You kind of alluded to the downside of that already, which is that it now becomes a new data management discipline that is neither familiar to the people from the file system world nor to the people from the database world. It's a hybrid, and so there is.
Sure.
That's an obstacle.
There's a learning curve there. Yeah. Like any other new technology, right? I mean, we're introducing, this is completely unrelated to WinFS. We're introducing something called DMF, which is bridging the manage at scale operational world that people deal with in data centers with the traditional database world. Yeah. And the semantics we're allowing people to express and manage through are very database-like, but they bleed into this other sort of view of the world. It happens. And those kinds of areas of convergence over time prove generally to be good, even though it usually creates stepping stones for folks. So it's kind of the file system piece. So I'm actually really proud of the work that's got on there. I mean, we're introducing the kernel driver in 2008. We give people this nice marriage between the worlds in this period of time, and then we get to take that next step in the next release and give people the complete picture. And at that point, we have unarguably we have integrated storage. I can live with the argument you don't have it yet, right? I mean, yes, I have file stream blobs in the database, which is a big step, right? I mean, I have the performance side and I have the database consistency side all in one package now, and that's a huge step forward. But when we have Win32, that's unarguably integrated storage at that point, right? The files are in the database, and there's no confusion about that. It's done in a compatible way that you have to walk up and work on it.
Mm-hmm. And how do you think that plays out in a world where the center of gravity starts to shift to the cloud? Right.
Well, cloud apps, there is no app in the world that does not need a database. Every major cloud app in the world uses a database underneath the covers there somewhere. Mm-hmm. and one of the things that we have definitely learned over the last few years has been that the fuzziness between unstructured data and structured data, that fuzziness is just increasing, right? The major online apps that I interact with have both, right? I mean, Hotmail has attachments. They have limitations on attachments because they have trouble managing sizes and whatever else, right? Why is that? They have, we have, things now where you can, people can create some space, they can put some files up there. But man, if you want any metadata around those files, too bad. It's just basically a dumb blob store, right?
Yeah. Well, I guess what I'm getting to here is that I think part of the challenge for WinFS as originally conceived with a heavy client component was how do you get to the network effects that you want, right?
Yeah.
And then that became about sync, and it became about handing things around, right?
Yeah.
And if, sort of 5 years later, right? If the center of gravity is, there's shared spaces in the cloud where these effects can happen.
Yeah, and I think that the technology we're building is underlying technology for the cloud apps.
Yeah.
That's one important piece.
Yeah.
And we have efforts, and all of our major properties are built on SQL, and they want to use this stuff. We have work going on there. We've pre-release work happening with those teams to take advantage of these features because they want it. So that's from a where I sit in the business standpoint. My first concern is am I able to provide value to our customers? And those are our customers. The people that are building the cloud apps are our customers, right? And then I think about the other question, which is really what's going to what is the opportunity for this? It's like WinFS. One of the things we used to say about WinFS was the world's best mashup playground, right? Sandbox, because you could set up these synchronization things. You could have those data coming in. You could have a much richer sort of experience overall of this data in all one place, as opposed to going, synchronously or not. You're still talking to one service at a time in the mashup world and trying to put things together in real time. What if you could dump that stuff in one place and then query it and know that things were up to date based on sync semantics, etc.? Will they build something like that in the future? Maybe. Do I think that the opportunity to build applications that solve real end user problems, building on technology like this continues to thrive? Sure. And when I think about the enterprise space, which is primarily where we sell SQL product, they want this, and they want the ability to bridge in, bring in data from other sources. There's a lot of business stuff going on. They want to have a repository for things. They want that thing to not be restricted on the types of data it has, and all this stuff helps with all those goals. You'd be surprised. I mean, SQL's behind some of the biggest cloud things on the planet. And this is, featured.
Terra Server.
As one of them, and Hotmail being another, and we have a long list of customers, some of which we don't sort of disclose generally, but SQL's back there, and our customers that have been building cloud properties have been struggling with this structured versus unstructured data problem, and FileStream alone actually gives them the solution to this. They don't need so much the Win32 aspect of it because they have enough, app development expertise in the mid-tier to bridge this stuff, reasonably well. But they do want the transactional consistency, the backup consistency, and all that stuff that FileStream gives them. Whether they'll take advantage of Win32 stuff, I don't know. That I think is really more for enterprise environments, apps built for end users, that kind of thing.
Would you say that as we get to the point where there is this flexibility to cross the boundary between structured and unstructured, and as that capability can live in a shared online environment, that we have the possibility of kind of iteratively reaching towards what the schemas maybe couldn't have ever been defined to be top-down? Like it becomes more of a, like you said, the ultimate mash-up playground, right? It's also the ultimate maybe, let's figure out what the schemas need to be on the fly.
Yeah, well, that actually leads to another interesting, we're going through the litany of the various technologies that have come from WinFS, and one of them is this notion of what I refer to as semi-structured records, right, where the schema is not necessarily all that well defined at the outset of the application, and what's the database's capability of handling that. So we had built WinFS around a feature called UDTs, and we needed, which is a database record, a column type, defined with basically CLR type system, a type. And we hadn't really finished the work in 2005, SQL Server 2005, so we were doing some special work to make the thing work. When we step back and look at that problem, by the way, we finished that stuff. We were doing large GTs, and we built a whole spatial data type on it in SQL Server 2008. It's all really good stuff. But one of the things we did when we stepped back and looked at the semi-structured data problem in a larger context, outside of just the WinFS requirements, was they really wanted the top level SQL type system to be extended in that way, not just the UDT types, to have that kind of arbitrary extensibility. So we did this feature in SQL Server 2008 that we internally refer to as sparse columns, where we get both. Actually, it's a combination of four things, I guess. One is a large number of columns. Right now, there's a 1024 limit on the number of columns in a single SQL table. That's being expanded at least 10, if not. Well, we're not quite done with development, so we'll see how far we get, but we're way widening that out. And that comes, of course, coupled with the ability to efficiently store data that's very sparsely populated across a large number of columns. So today in SQL 2005, we actually allocate, space for every column and every row, whether or not it's filled with anything or not. There's some space allocated for it. And so this gives us, the work we've done there allows us to, allow the columns to be very sparsely populated,
And this maps to exactly what the semantic web folks are all excited about now, right? In terms of being able to, have attributes basically scattered through sparse matrix.
That's right. And that leads to another thing, which is what we call column groups, column sets, which allow you to sort of clump together a few of them and say, that's a thing. I'm going to put a moniker on that, I'm going to treat that like a thing, and I'm going to treat those as an equivalence class in some dimension. So we have, column sets, large number of columns, efficient storage, and retrieval for that. And then we have something called filter indices, where you can, instead of creating an index that spans all the records in a table, you can specify basically what records it may apply to. So in indices today, you can say, well, I'm going to index on this column, and I'm only going to populate the index with these other columns. This gives you the ability to constrain it by rows as well. So only records that meet this particular query or within this set, based on the values in these columns, are going to be in this filtered index.
Well, one thing I think that comes out of this is that you mentioned, I think you used the phrase equivalence or equivalence class, right? And I think that when it's really cheap to make lots of those kinds of equivalences, then one of the things you get is the ability to let people call things however they want to call them, right? There can be lots of aliases and labels floating around, and people can have their own, sort of vocabularies, right? And you don't have to be so rigid about the names, and then as you discover equivalences, right, and you map them together, that's very efficient.
Yep.
Then so what, right? I mean, let people use the vocabularies they like. Yep. Don't try to dictate, because you'll never get in a committee people to agree how to call things. It's the hardest problem in the world, right? But if you can, if you let them operate in their own semantic namespace, right, and then you can, just kind of stitch the things together.
And that sort of bridges back to why the EDM is so important, the ND data model is so important, because it allows people to describe their own way of programming to and interacting with and describing the data that they want to deal with, right? Even if the underlying records are, whether they're identical or not doesn't even really matter. But I can take, one EDM model over some particular column within a column set and say that's kind of how I want to model and deal with the world. I can develop another one for someone else, and if there's various different applications, you can sort of have your own way of looking at things.
Right. And then from your sort of mashup playground perspective, right? If you bring these things together in an environment where it seems to me now you can cheaply equate this to that, right? Just build these layers and
that's exactly right.
Okay.
So that's the sparse column stuff of what I would call semi-structured record stuff. So the APIs we covered, the file systems we covered, the semi-structured records we covered. Piece we covered is sync. So it's funny when you look at, again, it's classic computer science learning curve. We got
there's before you do that, there's the kind of first-class relationships aspect of it, which I'm not sure I see where that emerges, from what we've said so far.
Yeah, give me an example what you're thinking of.
I mean, it just, in WinFS, as it was originally defined, a relationship was a first-class object.
Yeah, it's a first class object in the entity data model.
It is.
Yes.
Okay.
Yes.
Okay.
The notion of a relationship is part of the
Okay, so it's baked in the same way.
Yes.
Okay.
Absolutely.
All right. Okay.
Absolutely. Now, what we haven't done there is bridged an expression and understanding of that into the database itself, which we didn't really have in WinFS either, frankly. But it is something that we look at and we say, okay, if I have defined things with EDM, if I start from scratch, let's just ignore pre-existing world for a second. If I start from scratch, I describe my business entities. Can we then turn and prescribe how to store those entities in the most optimal way in the database without someone having to go through and describe the database schema themselves, and then get efficiency in terms of the ability to reason through that entity model directly in the database, right? So can the query processor basically understand something like a relationship and be optimal for navigating and doing queries through those semantics. We haven't bridged that part of the world yet. Now, it's certainly possible to create the right database schemas, that allow you to have good, query efficiency through your entity model. But it's, still intellectual work, right? Still, right. You gotta go and you gotta understand that. And if I create the right foreign key relationships, I've done the right thing. If I create the right table structure, and you gotta think that through. But we'd like it to be so that the database could effectively look at an EDM schema and say, I will create at least the appropriate indices, etc., so that when you are looking at things and querying things and examining things through that lens, through that view of this data, we can make sure that your experience is optimal.
Yeah. And then maybe if you figure out that's what you really wanted, you could really optimize it, but the odds are you're going to evolve it anyway.
That's right.
So all that redundant work that tends to happen around premature optimization, right?
Yeah. Well, I mean, and that sort of depends on how we go about solving the problem, right? I mean, if I have to literally relay out the physical structure of the records in order to bring things back to optimum, that's a problem. But if I can provide the right capabilities, based on understanding the model, build indices, etc., based in the model, it's easy for me to drop indices, right? And so we can evolve things as the usage evolves. So we haven't sort of finished that part. Excuse me, that's something that we sort of look at. So the sync stuff, like I said, went through a very classical computer science learning curve as well, where first we're like, okay, we need to be able to sync with the cloud, with other WinFS instances, their desktops, with server systems that may have whatever data. How hard can this be, right? We have merge replication. We know how to do synchronization. No big deal. And then we quickly realized how hard this was, and what should be more infamous than people breaking their pick on integrated storage should be people breaking their pick on multi-master replication.
That's got to be the worst problem in the world, right? I mean,
it's an incredibly difficult problem to get right, and there are all these famous examples. I'll leave some of them nameless because they're sort of not favorable to various products, whatever. But where data is really lost, where people set things up and they think things are going to happen, and in fact, I even had the experience on my smartphone where I have my Active Sync app set up to synchronize my favorites for my smartphone, so that really I do this so that when I replace my phone with another phone, that all the favorites trickle back to the new one. This does not really work. I mean, stuff just disappears over time and whatever else. And I'm not sort of blaming those guys, etc. But apps that have gotten it right for even a particular domain have become wildly popular. Like Lotus Notes got this right for a particular domain. Exchange and Outlook have gotten this right for a particular domain. Increasingly so, actually. They've done it through brute force and hard work. But that generalized solution to multi-server replication has been very, very difficult, very elusive. And so we cavalierly went down and thought we could solve this problem, and things did not work as we expected them to. And we did actually do this partnership with Microsoft Research. There's folks focused on this Microsoft Research, and at some point along that arc, we finally solved the problem pretty well. And we used to have this slide deck we used to call the executive IQ test, where we'd walk people through the algorithm, our multi-master synchronization reconciliation algorithm. And there's sort of a point where if you really get it, you should aha. You know what I mean? Like there really is this moment. It's one of these big build slides with arrows and things, all stuff going on, right? It's this example we walk people through, and there really should be this moment where people go, okay, I get it. And it's pretty obvious who gets and who doesn't get it, because they walk through the deck, right? Nonetheless, It is fairly sophisticated. I mean, this is not trivial. This is not something that ends up being a very simple solution to this very complex problem. It's actually a reasonably sophisticated solution to this complex problem, but it works. And we built it in as part of the last WinFS beta. And we had, as we were starting to realize we were onto something broader here. Again, there's one of these things where we said, it's classic system guys thinking, right? Well, I don't want to solve just this problem. I want to solve the problem and then use the solution for this thing, this particular problem I have, right? As they realized they're really onto something, they started to fork out a sort of componentized version of this that's now finding its way into a bunch of Microsoft products. Actually, it's found its way into some Microsoft products already. Like Live Favorites is an example, where if you use Live Favorites, you get favorites synchronized between desktops, whatever, and that actually works. Stuff does not get deleted. You can make changes here and there and figure reconciled correctly. And
well, I have to say there's a bewildering number of synchronization frameworks even within the company, and plus now, FeedSync, the new one, right, is kind of a big deal. So
yeah. So I think we've officially branded this the Microsoft Synchronization framework.
Okay. Yeah.
Has its underlying engine in it, which is this has this thing about knowledge, and like I say, it's fairly sophisticated, but it actually solves the problem really, really well. And I think they're on target to ship this thing in like 6 different products now over the next year, something like that. And so we're embedding this thing all over the place. And over the long term, we will make sure that it's embedded in all the pieces so that you'll be able to set up a SQL C database, which is the instance attachable, inside your app, lightweight database, for a rich web client or for your desktop app or for C or whatever. That thing will just be able to synchronize back to a larger SQL database, or I shouldn't say larger, to any SQL database, somewhere else. Synchronize to the cloud. We'll build it in as part of various cloud services over time. It's like I say, it's already in Live Favorites, but we'll start building into other properties so you can synchronize data. We really want this to be able to help solve the problem, not just for enterprises trying to keep clients with a rich cache, but really build this world where offline is possible. Where we used to say this about OneFS too, but the sync pieces alone really help get people a long way there. Where building an app like Outlook today, it's hard. Outlook has a semantic where the user experience is always there. You always can interact with your data that's there. And when you're connected, the thing will, under the covers, synchronize and reconcile and all that stuff for you. When it's offline, it still provides a consistent experience. To build that from scratch, that's really hard. Taking the sync framework allows people to go and build that experience without having to solve the hard multi-master synchronization problems. Because everyone thinks it's easy at first, because they have a client.
I don't think anybody thinks it's ezy, or they shouldn't think it's easy.
Maybe they shouldn't, but a lot of people do. I have a client, I have a server. Yeah. They could maybe change in one of a couple places. What was so hard to figure out about this? But they quickly realize that when people have multiple clients, they're attached to the same server, where changes happen. I left my house today, and my network had gone down. My internet connection had gone down for some reason. Well, I shouldn't say that, because I think it was actually up. For some reason, my Outlook instance on my main desktop at home wasn't talking to Exchange anymore for some reason. But I'd done a bunch of stuff. I had mail queued up, and on the way in, I'm on my smartphone, and I'm reading mail, working, deleting stuff, triaging stuff, right, traffic lights. And I get to work, and I start working on mail. And, there was a moment there where something recovered probably at home, and no less than 3 different clients all had their various changes they needed to reconcile with a server which had also taken its own changes. That's a hard problem. Like I say, the Outlook Exchange guys done a wonderful job solving that problem. But imagine if anyone could provide that same experience, that same flexibility for any kind of application.
We should get in the sense people are attacking you.
Lining up my
we should find a way to wrap this up. But I guess I would invite you to just think a little, or just kind of speculate a little bit about the original environment for WinFS, being end user desktop.
Yep.
Right. And now the environment in which many of these technologies have come to fruition, being the enterprise, let's say data center, back office environment, right? But there's there's a way in which these things must come together at some point, right?
Yep.
And so how does that happen, right? How does that how does the original sort of end user experience aspect of it come to fruition, right?
Yep. I completely agree that But the thing that sort of, I was very happy when we stopped WinFS to be able to take the technology forward, because I saw the broad applicability, not just in the problem space that we were working on, the solution we're working on it for, but for the general usefulness of the database, right? The job I'm in now, my job is to grow the usefulness of the database, right, to more uses, and the work we've done for WinFS was very much in line with that goal. And so I'm happy about that, but there's a part of me which is still unfulfilled relative to, what would it mean if every user's applications, all of the applications the user uses, was able to have some shared notions about some things, where the people in my lives had a there was a center of gravity around people, some person that various applications could plug into and use. And can we express that fully in a cloud way? Maybe there's a way to do that. Kind of harkens back to the old Hailstorm ideas.
Mm-hmm. Absolutely.
And we have things like like Astoria that are kind of expressions of that. So Astoria is a projection of entities over the web, and you look at some of that stuff and it's awfully familiar, right?
Yeah.
Both in terms of a WinFS way and in terms of a Hailstorm way.
Yeah.
So where that stuff goes, I don't know. I think we've made a choice right now just to incubate some underlying platform technologies for the web, and there's efforts going on at the company around that, and then allow the operating system team to cycle on the stuff that they had on their plates right now. But I think not too long here we will come out of those cycles and say, okay, we have all this fundamental technology. What's the next big innovation we can do, putting these things together? And this is kind of where we got tripped up, right? In that cycle, that old Longhorn cycle was, we're building building too much of the house at once. We had guys working on the roof while we're still pouring concrete in the foundation, right? We had the sort of roof held up with these odd, scaffolding systems, right? We're hoping somehow we'll be able to put it all together at the end of the day. And it just doesn't, you can't.
And the part that we haven't talked about is this, massive amount of UI complexity that was involved in just communicating to people notions like, things can be in more than one place.
Yeah.
Right? I mean, there's a tremendous set of challenges there, which is just completely orthogonal to...
That's exactly right. So we're trying to do all this stuff at once, right? And we had finished carpenters in, like I say, while we're still pouring concrete.
Yeah.
And it was, at one point we realized, okay, we're doing a little too much here. Let's decouple these things, and really to give this team the freedom to go off and take these underlying technologies, which we believe were fundamental to the database, and get them done, quote unquote, correctly, not just in a one-off way just for OneFS, which over the long term will mean more of it available sooner, right? I mean, even though the WinFS thing, may come later, that thing itself, but in terms of having symmetry between the programming, the system services that are available across data in all environments, it means that we will have that sooner, and that's a great thing. But I do want to at some point, see that place in my heart fulfilled around the shared data ecosystem for users, because I believe the power of that is just enormous. I'm at home, using one of the Adobe apps to tag photos and stuff, and I know it's just a loser, because I know I'm making this huge investment in this, which is just completely uncorrelatable to any of the rest of my universe, and it just kills me.
Yeah.
Given the background I have, the experience I have, knowing that I was building something that helped solve that problem just kills me. I'm making this huge investment, but I'm hoping one day that the utility will be written by somebody that extracts that stuff out and puts it into this shared data ecosystem they can get more value out of, and sort of believe in that. So I chose to use an app that's going to put things in standard EXIF headers and all that kind of stuff, because I believe that eventually we'll be able to pull stuff out of there. But for now we're letting the concrete dry, letting the framing get in place, and then we'll see how the rest of the house shapes out.
Okay. Well, thanks very much.
Thank you.